Hello and welcome to Solve for today's video and the solution to my cube problem. To solve this problem, we have to go back to the squared square. So now you have a square. We're going to try to find the smallest of those squares. Where can it be? Is the question we're gonna ask. Can it be at a corner? Obviously not, because if it's at the corner like this, and you could have a smaller square here and you have a bigger square here, that makes kind of a corridor, and you can't put any other square in the corridor because the width of this corridor is the width of the smallest square. So corner is not possible. Can it be on an edge? Well, if it's on an edge, or smaller square is on an edge, you're gonna have maybe another square here and another square there, and it's gonna make also a little corridor with the width of the smallest cube, the smallest square, sorry, and this is not possible. Another possibility, of course, is to have two other squares on the sides of our smallest square, and again we're gonna make a corridor here, and that's not possible. So, in conclusion, our smallest square on the squared square is somewhere in the middle of the square. Not on the edge, not at the corner. And that's what we're going to use to prove that you cannot cube a cube. Let's now imagine that we solve the problem and we could cube a cube, which means fill it with smaller cubes, all different size and a finite number of cubes. Let's check one of its faces, which is a squared square, obviously. And in red I put what could be the smallest square of that face. But since we're in 3D, we can turn over and see what's happening on the other side. We have, of course, lots of things going on here. All those squares we saw are actually the faces of cubes. And of course, our attention is going to be for the smallest cube on that face. This is not the smallest cube of our cube. This is just the smallest cube on which has a face on the face of the bigger cube. When you check the smaller cube, which is not on the edge or on the corner, well, it makes also a small corridor because it's surrounded by bigger cubes. So, on this red face of this little cube, the smallest cube of the face, you have to put other smaller cubes. And those cubes are gonna, on the red face, are gonna make, again, a squared square. Which means that when we check the other side, we are back to the same configuration as we started with a bigger cube. What does that supposed to mean? That's supposed to mean that there we're going to also find a smaller cube, a smallest cube. So we're going to have to fill up with the smaller cubes. And then we're going to have a smallest cube, which are going to give a space that we'll have to fill up again with smaller cubes, which are going to have a smallest cube, etc, etc, etc. So we're going to have to do that an infinite number of times. And that's against the rule, because the rule is to have a finite number of cubes. So we can't do that. So it's not possible, and that's the proof. I hope you enjoyed this puzzle and this proof, and see you next time for next puzzle. Bye bye.